Okay, so let's see, I was asked why is HO always equal to? Why is it never greater than or equal to or less than or equal to? Well, it can be. I mean, you can write it that way. If you've done the math assignment, you'll see some of those exercises are written that way. I honestly think the best way to do it is just do it equal to. And here's why. So here's something back from chapter 7, and it's about sleep. And you guys looked at this question, and I don't know if you looked at the textbook version of this, but you had one on the homework. And this is on average, people get 7 hours of sleep. So that's the hypothesized middle of this sampling distribution. So of this distribution, and then we say we get a sample of 50 people, and so now we're into a sampling distribution, and we've got this for these 50 students they sampled. That was the average. So that's certainly less than 7 hours. We got to decide now. In this exercise, you were just asked to find a confidence interval for the 6.2 hours and then test to see if 7 hours fell inside that interval. We could have done with the significance test. And what I'm going to do is pause this for a minute, pull up Rossman Chance, and we'll look at it that way. So one thing I need to remember to do before I go to use any kind of test is, because this is a sampling distribution, I've got to take the 1.25 standard deviation with the population, and divide it by the square root of 50. And when I did that, I got 0.177. So I'll show you that. So now we're going to run into this as a test. And because I know the population standard deviation, this is a one sample Z test. Let me get a board. Okay, so since the population mean of hours of sleep was 7 hours, I'm going to say the null hypothesis, no, the population standard deviation, population mean is 7 hours, and any variation or any change in that is just due to random chance, random error. So it could be above it, it could be below it. I don't really care. I just want to say if I can't reject it, I know that it's just equal to 7. Okay, so you see the way I'm not saying less than equal to, I'm just saying it's equal to 7. It can vary either side of it. Now, for this sample of 50 people, we came up with let me write it as H1, that's what Dr. Steven writes. He found out a mean of less than 7. So we're going to say this is a left tail test, but just say it's less than 7. So that's where I'm incorporating that it's significantly different from 7. And then remember, I had to find the standard error or the sampling distribution or the standard deviation for the sampling distribution. That was 1.25 divided by the square root of 50. And I got on my calculator, when I did that, I got this 0.177. Okay, so now what's the test statistic? Well, I guess I do need to calculate it, don't I? Because this normal curve generator is not doing that for me. So it's a z-score. I'm going to do 6.2 minus 7 over 0.177 here. 0.177. And I can just see from the way this David Lang calculator labeled it, that's a z-score of 3. So I know it's going to be less than that. But let me actually get the test statistic, because I want you to tell me the test statistic. So what's that? 0.8 divided by 0.177. I'm getting negative 4.5-ish. So it's about negative 4.5. So that's the test statistic. There's the p-value is practically 0. We're going to reject HO. Looks like, for at least for college students, they are getting less sleep on average than everybody else. Okay, so that's why we don't really care whether it's greater than or less than. The HO, I mean. So I hope that answers your question about why do we just always write equal to for the null hypothesis. Okay, I think it's a safe way to do it.